Okay, for math today, because we've been gone for so long, we're kind of easing our way back into math. So we are working on our math packet and working on Khan Academy. Our friends at home have it a little easier because they have internet, and our internet is still not quite up working yet, but Mr. Landman is working on it. So by the time we get to it, maybe when we have work time, we'll be able to work on Khan Academy in the classroom. If not, you'll just be working on math packet and then working on Khan Academy at home. You will notice on the assignment page I have on the board, you'll see that we have a CO we're doing tomorrow. And then we're wrapping up. We're going to do a review of the COs that we did before break. And then we have our practice test is on Thursday already. Whew. Real test on Friday. So we have today we're working on Khan Academy and the math packets. Tomorrow we're doing our last CO. Wednesday we're going to review everything because I know what we did before break 2 weeks ago. I don't remember what you guys were doing. I don't expect you guys to really be on top of it. So we're going to review stuff on Wednesday. Make sure we're back in the groove. Practice test Thursday, real test Friday. So let's look at this math packet. That first page, when you fold a square paper, the resulting rectangle has a perimeter of 39 inches. So if we have a square, oh, now why is my pen not working? This, oh, you're right. Sometimes it does need to warm up. Let's see. Maybe recalibrate. You recalibrate it so it works. That's usually not what I need to do. Let's try recalibrating it real quick. Oh my goodness, that's loud. That's why I like you know what? We've got to do it. We're on the wrong. That's why it was doing it on the wrong screen. There we go. Oh, the joys of technology. I gotta tell you, I did not miss this for 2 weeks at home. All right, let's see. Aha, now it's working.
So you were drawing on your email?
I was drawing on the email on that screen. Okay, so we have a square. And it says the resulting, you fold it in half. So the resulting rectangle has a perimeter of 39. What is the perimeter of the original square? So first, if you're at 39 here, you need to figure out what your lengths and widths are. So how could we find that? Oh, Edward, I asked for that not to be out while we're learning. If we know it's 39 all the way around, how could we find out what do you think, Paul?
Well, you see our math packet, if we fold this fold it like this, there's still an extra fold to make it a square. So if you find half of 39, which is 19.5, and then you times it by 4, it'll get the full perimeter of the original square.
So if it's 19.5, because he did 39 divided by 2.
Make another fold. And that would be the extra fold, which is 3 folds total. And then you times it by 4, you get the answer. Just 1/4 of the paper.
Okay, it's not the way I figured it out. Well, I'll have to work that through and see if we get the same answer. What did you do, Izzy?
Well, I just thought since 39 is half of it, and the full thing is, 39 is half, then you would have to times it by 2 to get full.
Why would that not work?
Because once there's no side.
Because this side is actually going to be up here, But if we have these 4 sides and we times it by 2, we would have the middle twice. And you don't want the middle at all.
Mm-hmm.
Do you see what I'm saying, Izzy?
I said it backwards.
So if you times it by 2, if you times 39 by 2, which is in essence what you're doing, Paul, timesing a half of it by 4, you're timesing it by 2, 39 by 2. That's why I don't think that's going to work. Because we can't have this middle. We don't want to include that in it at all. Maddie?
You could do, I'm pretty sure that you can do the sides. So if you divide that 19.5, or did you divide it to 19. Sorry, you add 39, you double 39 and then you do it on the other side. But
39 is for this whole rectangle.
like the area?
That's the perimeter.
Oh, so you would divide, or you would figure out what the
I did what Paul here did here. I did 39 divided by 2, and that got us the 19.5. That tells us half of that rectangle is 19.5. So if the whole thing was 39, half of it is 19.5. So then you have to figure out, what is this length? If this plus this is 19.5, how can you figure out what half? So this would be, you got 3 sections the same size, right? Because half is the same as this half, which is the same as this half. That's the only clues I'm going to give you to help you on your way. Uh-huh. So you're going to work on that a little more, but keep in mind that we know that this whole rectangle is 39. Half of it would be this much. And that's 19.5. Nope, I'm recording. Go sit down. So I'm not giving us answers. I'm just helping us get started and seeing if we can work from there. This is not due until the 25th. You have time to work on it. So our next one, Tom has 4 different colored shirts, yellow, orange, blue, and red. He has 4 pairs of shorts, brown, black, green, and purple. How many different outfits can Tom make? It's a logic problem. You got to work it out. If he's got a yellow shirt, what options does he? How many options does he have for the shorts? If he's wearing his orange shirt, how many options for the shorts? Figure out how many different outfits he can put together. The next page is our 5-card challenge. We know how to do those. Now we have some formulas. So you need to find the perimeter and the area. And we can see that we have a semicircle and a triangle. So the perimeter of a circle is its circumference. So the circumference of a circle equals 2 pi r. What is the r? Radius. The radius, remember, is halfway. So it's from the middle to the end. We can see here that from here to here, it's 7. Is that the radius? No, that's the diameter. That's going from end to end. We want halfway from there. So we want from the middle to the end is the radius. So what do we have to do to our 7? Divide it by 2. So our radius would give us that 3.5. Now, is this a full circle?
No.
It's a half a circle. So divide it by 2. Okay, because it's a half circle, not a full circle. We know how to find the perimeter of the triangle, just the outside. For a triangle, you just want the outside. You don't want that inside line because perimeter is the outside. So you just add. Okay, there's no formula for that. Paul?
So then after we divide it by 2 after we get the whole thing? Like this.
What I did, Paul, was I was multiplying by 2 and dividing by 2. I canceled them out. And I didn't even do that part. Because multiply by 2, divide by 2, it cancels out. So it's just pi times r.
That's it.
For the circumference of the semicircle. Okay, then we need our area. The area of the circle, remember, is pi r squared. But again, it's a semicircle. So do pi r squared and then divide by 2 because it's a half a circle.
Then you would have to divide it by 2.
Yes, you have to divide it by 2 because there's no 2 to cancel out. And the area of our triangle, base times the height divided by 2. Because base times height would give us a square, triangle is a half of it. So it's the base times the height divided by 2. So you just have to plug in the right calculations, do the math, adding together your circumference and perimeter, adding together the 2 areas. Shh, still recording, so voices are quiet. This page is pretty self-explanatory. It's one of the easier patterns that we've had to do. Pre-algebra, it's just going on to number 12. So plug in how many blocks there are for each figure, find the pattern to see how you're increasing for each figure, and continue that pattern to number 12. This one we need to talk about. All right, working on the cone. You need to draw the net. So pretend that you cut that cone open and lay it flat. So think about what that's going to look like. Then this is what you need to know. And to find the figure's surface area. To find the surface area of a cone, what you're doing is you're doing pi r slant plus pi r squared. Because when we lay that cone flat, it's a goofy shape. It's not a rectangle. Think about if you have a cone and you cut it open and you lay it flat, it's not a rectangle. It's a goofy shape. So what we're doing is we do pi r slant. So this is your slant. So you have to show me what your net would look like. Then plug in your numbers. So this, we know pi r squared is the circle, but pi rs will be the goofy shaped part of the cone when it's laying flat. So it's pi rs, s meaning slant. Okay, that'll give you the surface area. Then the next page, working with that cone, write the formula for the volume of a cone. So the volume of a cone is pi r squared height divided by 3. Because it's a cone, it's not a cylinder, it's a cone, we're taking that out of a cylinder, so we're dividing it by 3. The volume of a cylinder is pi r squared times the height, but because it's a cone, we divide it by 3. So then you have to plug in the calculation. So plug in your numbers. So we know pi is 3.14 times r squared. What is r, Izzy? 7 squared times our height divided by 3. So remember, when we do something like this, it's very important, and I had people forgetting this last time, it makes a difference, order of operations. What is the first operation we have to do here? Rhino? Exponents. We don't have any parentheses, but there is an exponent, so you need to do that first. Always remember your order of operations. So if I say 7 squared, is that 7 times 2? No.
7 times 7.
It is 7 times 7. There's a 2 there, so you multiply that 7 2 times. 7 times 7.
Wait, what's R?
R is your radius.
No, I'm saying in permanent.
Oh, radicals. So the square root. Okay, so you write your answer to this calculation. You're going to put the answer right here. Then we're doing pre-algebra. A cone has a volume of 131 meters cubed with a radius of 5 meters. What is the cone's height? So you're going to plug in all the information that you know into the formula. So we know there's pi, right? We know the radius. It's radius squared. Then we don't know the height. Divided by 3 equals 131 meters cubed. What are we going to solve for? The height. We're solving for the h. So remember what you know about your algebra. How can we get h by itself? So if we're dividing by 3, what are we going to want to do? Multiply by 3, both sides. If we're multiplying by pi, we want to do the opposite. If we're multiplying by 5 squared, we want to do the opposite. Okay, so get h by itself, and you'll find what the height is. So remember, doing the opposite. Do that algebra. Whatever you do to one side of the equal sign, you do to the other side. So if we're dividing by 3 here, we want to multiply by 3 to cancel it out, so we have to multiply this side by 3. Okay, so you have to do it one step at a time. Is that making sense? Okay, it's a lot of math, but when you take it one step at a time, it's not hard. It's just you have to go step by step. That's the thing with math, is you have to remember to slow yourself down and do it one step at a time, and you will find the answer. So let's go to our next one. This is a new page for us. The Jordan curve theorem. So, let's read what it says. The figure on the right, so right here is an example of the Jordan curve theorem. Notice how the gray section of the figure is enclosed and connected, meaning you can get from any point in the gray section to any point in the gray section without leaving it. The same is true for the white section. You can also consider the gray section to be inside of the figure and the white section to be the outside of the figure. The Jordan curve theorem simply states that a closed curve divides a plane into an inside and an outside. So for each of the figures below, determine if the point, that dot, is on the inside or the outside of the figure. So if you're moving that dot around and you cannot get out, it's on the inside. So you're going to write inside right next to it. If your dot can be slid out, then it's on the outside. So for each of these 5 shapes, you need to decide if the point is inside or outside. Now he has a little tip here. It says if you're having trouble, the Jordan curve theorem also states that you can determine inside or outside by imagining a straight line going from the point to going from the point to beyond the boundary of the figure. If the line crosses the curve of an even number of times, the point is outside. If an odd number of times, the point is inside. Honestly, I tried doing that for this point in here, and it was, I got lost counting my points. This smiley face. So I actually just traced it through with my finger, seeing if I could get in, if it was stuck on the inside or if I could get to the outside. Okay, you just have to have patience and work with each of those. Shh. We know our polynomials. And now this page, logic and interpretation. This is a new page for us. Look at how you're going to answer this. We have one triangle, and after that triangle comes a triangle inside a square. So if we're going to follow, guys, I need you paying attention. If we're going to follow the same logic, if this triangle turns into a triangle and a square, what is our pentagon going to turn into? Pick which of these three shapes it's going to come next, and you're going to circle the correct shape that will come next. So these three shapes in the box are your choices. Decide which one would logically come next. So if we're looking here, if we go from an open circle in the lower left corner to a closed circle in the upper right corner, what would come next? If we have an open circle in the lower right corner, which one of these would come next? Circle the figure that comes next. It's kind of like a pattern, yeah. Okay, so figure out how one shape turns into the next shape, and then go with that same pattern for finding out what comes next. So again, for today, we are working on Math Packet. We're going to check in a little bit to see if we can get into Khan Academy. Khan Academy is due on Thursday night, as always. It was assigned today, so I don't believe I did 4. I think I only did 3 because we didn't have the weekend to work on it. Remember, we will be doing review on Wednesday, practice test on Thursday, real test on Friday. So that is coming up this week. For my friends at home, I hope you are well, and I hope this helped you with the Math Packet. We do have the Math Packet attached to the assignment for today, so you can print that out at home. Otherwise, some of us are going to be picking up our supplies at school. I will include a Math Packet tomorrow afternoon for you to have a hard copy, or you can wait until you come back next week. Have a wonderful day.